Okay, so the biggest thing with polygons is classifying if something is regular or irregular. Remember that it has to be a closed shape to be a polygon, and then regular is with no curves, sorry. And then regular is all angles and sides are the same measure. And so like in example 2a, they're not all the same measure for the angles, and so therefore this is irregular. And then for concave or convex, if it caves in, it's concave. So example B is concave. You can see it's caving in the corners. But that's convex. This is irregular. Anything concave is irregular. And this last one, they're all the same angle measures, all the same side measures, so it's regular. And then it could be convex or concave, but because it's not caving in, it's convex. Okay, sum of interior angles. The sum of the interior angles uses the formula n minus 2 times 180. So if it's a heptagon, then it's 7 sides. N is the number of sides. And so 5 times 180, which is 900. That's the sum of the interior angles. If it says each interior angle, that's when you actually divide after. So n is 16 in this case, because it's a 16 gon. So 14 times 180, which is 2520. But then we have to divide by n because it said each. So I'm dividing by the n, which was 16 sides. So each angle is 157.5 degrees. And then for example C, it's all interior angles. We have to know what this would add up to. Since it's a pentagon, we're going to do the 5 minus 2 times 180. So we could see what it adds up to. It adds up to 540 degrees. And then you just take all of these angles, like 18C plus 32C plus 32C plus 18C plus 35C equal to 540 and solve from there. Page 49, example 4B. These are exterior angles, and so it's going to add up to 360 degrees. Same thing actually for example A, exterior angles. So this one would be 360 and it's each, so divide by 20. For example B, it was 33B plus 16B plus 10B plus 28B plus 15B plus 18B is equal to 360 degrees because they're exterior. And then you solve that to solve for B. So unit 12, naming all of these, a chord goes from edge to edge, such as JM or KM. A secant crosses through the circle. It's a chord that keeps on going, so you could call that line JM. I want to put the KM here also. A tangent touches at one point outside the circle, so that would be line M. They didn't give me two capital letters, so I can only name it line M. The diameter goes through the center, so KM, line segment KM. The radii goes from center to the edge, such as JL, or KL, or LM. Those are all good examples. Find the length of each radius. So for circle S, it's looking like about 1.5. For circle R, the radius is 2. Okay, then it says identify the point of tangency, so where they're both touching, which is going to be -2, 0. and then the equation of the line in which they both touching. The equation of this line is the opposite of the axis. It's in line with the x-axis. It's going to be a y equals, and then you take the y value, 0. Page 55, example 4. When two tangent lines meet at one point outside the circle, these are equal to each other. So you're going to set them equal to each other and then solve. I'm on page 59. Example 2. Find the measure of arc BCD. B to C to D. So it really helps to look for, one thing you have to know, central angles equal the arc measure. So like arc ED is 52 degrees, for instance. And if you notice, this is a semicircle. From B to C to E, basically, is a semicircle. So if that's 180, then we could subtract out the 52, and that gets us our arc measure. 128 degrees. In example 3, if the chords are equal to each other, then the arcs subtending that chord also equal each other. So you set those equal to each other and solve. 7n plus 11. Page 61, example 4. This is where you want to draw in another radius, like Rn, for instance. And if the first radius from R to M was 17, then so is R to N. And then you have a little right triangle there, so it's 17. This little piece is 8, and we're wondering what N to that middle point is. And so we would do Pythagorean theorem. So that's 8 squared plus b squared equals 17 squared. 64 plus b squared is equal to 289. What the heck is that? 289 minus 64. 225. B squared is 225. And then square root both sides, and b is 15. And if that piece is 15, then we would double it to get the full length of NP. You're going to need to memorize these formulas. So for 12.3, the area of a sector, it's the area of a circle, but we're only taking part of that, so that's the times m over 360. So if the radius is 12, then times the central angle, 131, over 360. And then you calculate that to get your answer. To find the area of the segment, it's area of the sector minus area of a triangle. But the problem is a lot of times you have to figure out what the triangle is. So if this is 120 degrees, we can make a right triangle. We just cut the 120 in half, so we got 60 right there. So I'm just going to redraw this so we can see it better. There's a right triangle. That part we cut in half is 60. The hypotenuse is 9. And so if this is a 30, 60, 90, 9 is 2x, since it's across from that, which makes, it goes x radical 3, 2x. So 2x is 9, so that makes x is 4.5, so this is 4.5, and the other one's 4.5 times radical 3, which is like 7 point, we'll call it 7.8. So we have 7.8 is across from 60, across from 30 is 4.5. And so for the area of our triangle, the whole base then would be 7.8 doubled. So 15.6. Our height was 4.5. Mama. 1/2. Beautiful. Put it on the table though. Pi times the radius was 9 squared times 120 over 360. Treat these as two separate problems, then subtract them, and you get your answer. Segment length is not asking for the degrees, it's asking for how long would this be if you took like a tape measure to it. So segment length is 2 pi r because it's circumference, but you're only taking a part of it, so m over 360. So in this case, it's 2 times pi times 8 times 134 over 360. Inscribed angles are half. Inscribed angles go to the edge of the circle, and they're half of its arc measure. So measure of angle P, R, U. This angle has to be, the angle is equal to 1/2 of the arc. So if we're looking for the angle, then we plug in the arc is 118. And so 1/2 of 118 is 59. So measure of angle PRU is equal to 59 degrees. Now for arc SP. Remember, the angle is equal to 1/2 of the arc measure. So if the angle is 27, it's equal to 1/2 of the arc. We'll call that x. You could solve this just by multiplying by 2. And so x is equal to 54, which means measure of arc SP is 54 degrees. And then in example 3 on page 70, this inscribed angle, if you look at the cone it makes, the ice cream is a semicircle. So I know this is 90 degrees. So I would do 5a plus 20 is equal to 90. And you just have to solve for a. On page 73, we have a lot of theorems here. So if you're looking for measure of angle EFH, F is an inscribed angle. The angle is equal to half of the arc. So half of 130. And so the angle measure is 65 degrees. Okay, in example 2, these are inside angles. Angle AEB is an inside angle, but it's not a central angle. So for the inside angle, it's equal to half of the arcs added together. So if we're looking for the inside angle, then it's equal to 1/2 of 113 plus 139. That's different than example 3, because in example 3, it's an outside angle. So the outside angle is equal to 1/2 of the arcs subtracted from each other. Usually I do arc 2 minus arc 1 just as a reminder to do the big arc first. So the angle is equal to 1/2 of the 87 minus 7. So x in this case, which is the angle, is 40 degrees. Page 79, example 1, it's chord-chord product theorem. So you're multiplying the parts of the chord. So 14 times x is equal to, on the other side, 7 times 10. and then you end up getting 14x equals 70, and x is 5, but it also asks for the length of each chord. So GH would have to be 14 plus x, which is 19. And FE we could have already figured out even without finding x, because it's just 7 plus 10. It's just the lengths, we're adding them. Okay, in example 3, on page 79, we have two secants. The rule for secant is total or whole times outer equals whole times outer. Just remember that whole is adding. So for DE, it would be 9 plus 7 times the outer part, 7, is equal to, for GE, it's x plus 8 times the outer, which is 8. And so then we can follow PEMDAS or distribute, whichever one you want. And so we should get 112 is equal to, distribute there, we get 8x plus 64. Subtract 64, so I get 48 equals 8x. Divide by 8, and x is 6. On page 80, example 4, that's a secant and a tangent. So for the secant, it's whole times outer, and for the tangent, it's equal to tangent squared. So the whole, remember we add them, 15 plus 5 times the outer, which is 5, is equal to the tangent squared. So 15 plus 5 is 20, times 5 is 100, is equal to tangent squared. Square root both sides, and x is 10. Example 1a, you're going to have your ordered pair, your center, which is h comma k, and your radius, which is 4. So the equation of the circle, x minus 2 squared plus y minus 2 squared is equal to radius squared. And you actually have to square that radius to have it be simplified. Okay. I don't think you have to do example B, but just so you know, the point that it passes through is xy, and this is hk. So you could plug everything in and solve for r. And then when you're done solving for r, plug in the hk and r like we did in the last problem. For graphing, you take the center, which would be the opposite sign. In example A, it's just 0, 0. So I'm going to go to example B. So the opposite sign would be 3 and negative 4 for the center. And then the radius is the square root of 9, which is 3. So we go to 3, negative 4. And then we go out 3 on every side.